Hello everyone, in this video I will go over the solutions to study guide 3 or for exam 3. So the first question, it requires you do a few things, so this is a pretty good exercise. So at the bottom, this is technically some formula. So you have, this will be A and this will be B. So essentially this is you follow the sum formula for sine. This is technically, remember, sine A cosine B plus sine B cosine A. So that's the sum formula. And then you also need to remember inverse functions. So this is telling you the sine inverse of 3/4 is equals to A, which implies the sine A has to be 3/4. So then you do a triangle, a right triangle. Remember, sine, this is 3, and this will give you 4, and then you use the Pythagorean theorem. This is the square root of 7. Now, in a similar way, remember the secant inverse is the same thing as saying the secant inverse of 12/5 is equals to B, which means secant of B has to be 12/5. But if secant is 12/5, that means the cosine of B is 5/12. And then if we do a triangle 2, then this will be 5, this will be 12, and you use the Pythagorean theorem. This is the square root of 119, which is not a nice number, but, and by nice I mean you cannot simplify more. So then all you have to do is plug in the values here. So sine of A, right? You know, sine of A. So this is we made sure this is A, this is B. So sine of A is 3/4. Then cosine of B, raise A by 5/12. Then sine of B, since this is B, sine is this over this, which would be the square root of 119/12. And cosine of A will be this over this. So that's a radical 7/4. So then if you simplify a little bit more, this will be 15 plus the square root of A 33, everything divided by 48, because 4 times 12 is 48. Okay, and that's it. All right, so let's move to number 2. This one is telling you if sine of x is equals to 5/13, find the double angle. So essentially, it's asking you to find sine of 2x, cosine of 2x, and tangent of 2x. Now recall that sine of 2x is the same thing as 2 sine of x, cosine of x, and the double angle for cosine, it has 3 formulas, but let's go with the first one. This is cosine square x minus sine square x. And once you finish part A and part B, then this is just going to be sine of 2x over cosine of 2x. There is also a formula, but it's a lot easier to just plug in the answer to this one and this one. Now notice that we do know what this is, okay? So you know that sine is equals to 5/13. So you have this, but we don't have cosine. So for that, we're gonna do something very similar to what we did here. So you need a triangle to get out the information, okay? So therefore, the triangle will be the following. So you have x, that will be the angle this time, and sine is 5 over 13, which means this is 5, this is 13. By the Pythagorean theorem, this is 12. Okay, so therefore, let's start with this one. So sine 2x, so that means sine 2x will be 2 times sine of x. Sine of x is 3 over 13, and cosine of x is 12 over 13. Excuse me. You multiply everything, this will give you, sorry, this is 5, not 3. So that's 10, that's 120 over 169. Okay? So then if we do the same thing for cosine, notice that cosine 2x will be cosine square, which will be 12 over 13 squared, minus sine square, which is 5 over 13 squared. And if you simplify, this will be 144 minus 25 over 169, and the whole thing is 119 over 169. So then finally for tangent, well, this one, sine of 2x, we found it to be 120 over 169, and cosine was 119 over 169, and 169 cancels, so this is 120 over 119, and that's it. All right, so number 3 is asking us to verify that this side is equals to this side. Okay, so you can go from left to right or right to left. So let's say this is the left hand side, this is the right hand side. So let's start on the left hand side and show that it's equals to the right hand side. Okay, so start with this. You have 1 minus tangent x over 1 plus tangent x. And actually it may be easier to go from the right to the left, but let's go from the left. So let's just change everything to sine and cosine. So notice that on the top, this will be 1 minus sine x over cosine x. And obviously in the bottom, this will be 1 plus sine x over cosine x. Okay. So then you will find the LCD for the top, the LCD for the bottom. For both of them is cosine. So this is what I mean. Look, notice the 1 minus sine x over cosine x is the same thing as cosine x minus sine x over cosine x. All right, so therefore the top is going to give you cosine x minus sine x over cosine x. Then remember that to divide fractions, you multiply by the reciprocal. By that I mean this: you have a over b divided by c over d. This is the same thing as AD over BC. So therefore, on the bottom, you're going to get now cosine x over cosine x plus sine x. So notice that this will cancel. And also, to be sure that this is clear, this is this part, and this is this part. The cosines cancel, so therefore you end up with cosine x minus sine x over cosine x plus sine x. Now this doesn't look anything like this yet, so we're gonna use the trick that we used before, multiply by 1. So what do we need for 1? We're going to multiply by this, cosine x minus sine x divided by cosine x minus sine x. So notice that this is just the number 1. So you distribute on the top, you're gonna have cosine square x minus 2 sine x cosine x, that's by using FOIL, and then plus sine square x. And then on the bottom, you're gonna have cosine square x minus sine square x, which by definition, this is already telling you this is cosine of 2x. Also notice here that you combine this one, cosine square plus sine square is equals to 1. So therefore from here you have 1 minus 2 sine x cosine x, and then this is cosine of 2x. But remember the 2 minus sine x cosine x, that's exactly the double angle formula. So this is sine of 2x. So therefore this is 1 minus sine of 2x divided by cosine of 2x, which is the right hand side, and that's it. All right, let's move on to the next one. All right, so here you need to show that again that the left is equals to the right. Let's start on the left hand side again, and notice again change everything to sine and cosine. So tangent is going to be sine theta over cosine theta. Now here, to be clear with this one looks a little annoying, so we can write this to make it easier. So notice this, the 1 over cosecant, remember, is equals to sine theta. So therefore this part is essentially sine q. So therefore this is sine theta minus sine q theta. This is over cosine. This is over cosine 2. So therefore now you have the same denominator. So therefore you can simplify this as just sine theta minus sine q theta over cosine theta. Okay, so the reason how I got sine q, okay, let's say you have x squared divided by 1 over x, and you have that, notice this is x squared times x, which will give you x cubed. So that's how you get x cubed. Then you can factor sine, and this will be 1 minus sine squared theta divided by cosine theta. But remember that 1 minus sine squared is the same thing as cosine squared. So you have sine theta times cosine squared theta over cosine theta. So this cancels one of this, and you are left with sine theta cosine theta, which is the right hand side, and that's it. Okay. All right, so let's move on to number 4. And number 4 is asking you to figure out this. If these two are the same, and by the same I mean the same function, one inverse and one no inverse, regular one, the answer is automatically just the argument, which is 7 pi over 4. And that's it, which is pretty straightforward. The one that's a little more tricky, and it's part B, and technically you can do part A just the same way as part B, what I'm going to do right now, but there is no need to go through all of the pain and suffering on part B if these two are the same, which usually they are not. So most of the problems will be like part B. So how do we solve that one? Well, we're going to call this theta, and essentially the question is, what is cosine of theta? That's what you need to figure out. So therefore, we have sine inverse of x over 9 will be equals to theta. This implies that sine of theta has to be x over 9. And then you had to create a triangle, just like we have done multiple times. So this is theta, this is x, this is 9. And therefore, this will be 9 minus x squared. So therefore, this is identical to just finding cosine of theta. Well, you go back to the triangle. Cosine of theta will be this over this. And that's it. So it will be the square root of 9 minus x squared over 9. And we're done. All right? Okay. Oh, yeah, sorry. I'm missing this. So, sorry, let me go back to this. Number 5. All right, so for question number 5, it's asking to find all the real solutions between 0 and 2 pi. So from here, if we leave cosine by itself, notice that cosine x is equals to radical 11 over radical 44. Well, notice that radical 44 is equals to 4 times 11, which is 2 radical 11. So therefore, this will be radical 11 divided by 2 radical 11. This cancels, so this is just equals to 1/2. Now, this is one of the special triangles that we have done now hundreds of times. But in case you forgot that, remember that cosine is positive here and here. That's for cosine. So if cosine of theta is 1/2, that means that the reference angle has to be 60 degrees or pi over 3. So therefore, the solution, if it is here, is pi over 3. And if it is in the last quadrant, is pi over 3 for this one. That's it. All right. Now, for this one, you're required to use the double angle formula, which now we have used 3 times. Remember, this is equals to 2 sine x cosine x minus cosine x equals to 0. Factor the cosine, so this will be cosine x times 2 sine x minus 1 equals to 0. So that means that cosine x equals to 0, or 2 sine x equals to 1, which means cosine x equals to 0, or sine x equals to 1/2. For this one, the answer is x equals to pi over 2. That's the only one that gives you 0. Actually, also 3 pi over 2. And the one that give you 1/2, the reference angle is 30 degrees, or pi over 6. So therefore, the answers are x equals to pi over 6. Remember that sine is positive in the first quadrant and the second quadrant. So therefore, the reference angle will be, therefore, if it is 30 degrees, it will be 150, so it should be 5 pi over 6. This is the same thing as 150 degrees. And that's it. So these are the 4 answers for this problem. All right, so finally, for this one, notice that we're gonna use the same method we did before. So you have to use the following. Remember, if you have x and y, the basic function, which is cosine, the basic points we're gonna need is, you need this to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the values for cosine here, this is 1, then 0, -1, 0, and 1. Okay, so we have used that before. We're going to use those values again. Remember, the way we did this problem before was that you had to solve for essentially these values and create a new table. So this is what we did last time. So remember, you start with 3x minus pi over 2 should be equals to 0. And then you solve for x, you had 3x equals to pi over 2, which means x equals to pi over 6. So you should check the algebra on this. You had 3x minus pi over 2. Now it has to equals to pi over 2. So you'll have 3x equals to pi, which means that x equals to pi over 3. And then move on to the next one. This should be equals now to pi. And you should check the algebra on this. You have 3x should be equals to 3 pi over 2, which means x equals to just pi over 2. Once you simplify everything, you have 2 more to go. 3x minus pi over 2 should be 3 pi over 2, which means 3x should equals to 2 pi, and that means x equals to 2 pi over 3. And then finally 3x minus pi over 2 should equals to 2 pi. And then from there you have 3x equals to 5 pi over 2, which means x equals to 5 pi over 6. And now we create a new table. So you have x and then y. So the values for the table, remember here is pi over 6 now. And now this will be 1 plus 2, y2, because this 2 right here. So that will give you 3. And then the next one was pi over 3, so it should be now 0 plus 2, which will give you 2. The next one is pi over 2, so that will give you minus 1 plus 2, which is 1. The next one is 2 pi over 3, so this will give you now 0 plus 2, which is 2. And then finally you're going to have 5 pi over 6, which will give you 1 plus 2, and it goes back to 3. Then when you do the graph, okay, so this is 1, 2, 3, and you start in pi over 6, pi over 3, so you plug in these values, pi over 2, 2 pi over 3, and then 5 pi over 6. So when this is pi over 6, remember this was equals to 3, then this was 2, and it was 1, back to 2, and then back to 3. And remember, the graph of cosine always has to look like this. From here you can see that the period is 2 pi over 3, and the shift is pi over 6. You can see that either from here, this is the shift, or remember that you have 3x minus pi over 2. So if you factor the x, this will be, sorry, you factor the 3. Factor the 3, this will be x minus pi over 6. So therefore this is the shift. And that's it.